In this video, we're going to talk about some general rules regarding how to develop null and alternative hypotheses. In any type of hypothesis test that you want to run, we have to have two sets of hypotheses, a null hypothesis and an alternative hypothesis. These are usually two opposite statements about the population parameter that we're trying to test. And then now we're going to talk about some ways that we can develop and we can formulate the null and alternative hypothesis. So first of all, it's very important that the notion of null and alternative hypothesis is really related to the context of the situation and context of the problem. And the person who wants to formulate null and alternative should have a knowledge of the situation and not just in a statistical manner. So you should really know what is it that you're trying to basically conclude at the end. So, and usually it's very helpful. This is really a very tricky, it can be a very tricky and complicated process developing null and alternative, and it most of the time require experience. Now we're gonna go over some techniques that can help in developing null and alternative. One good techniques would be basically to ask yourself before running this study, before collecting the sample, ask yourself, what is the purpose of this study? Why I'm collecting these sample data? And then, and even more important, what are the conclusions that we're hoping to make? So what are our hopes? What are the things that we need evidence? So if you have two opposite statements, which one is the one that you hope to get? Which one is the one that most people assume? What is the common belief? And which one is the one that you require claim? So the item that you hope to get, the statement that you hope to find, or the statement that some people are claiming, that usually should go to alternative hypothesis. And when you have an assumption about something, let me show you the next slide. So if you have a research question, and research hypothesis or research question is usually a statement about population parameter where there is a claim here. This is something that if you want to claim that, you need strong evidence for this one. So if this is the case, you just put it in the alternative hypothesis, and then the opposite statement would go to the null hypothesis, right? Or if you have something that you hope to support, if you have a claim, if you have something that you hope to support, again, this should go to the alternative hypothesis. If you do not have a clear research question, if you don't have a clear research hypothesis, what you can do, you can start with a common assumption, with a common belief or conjecture. And then you take that as your null hypothesis. Now you have a null, you form the alternative. Because these two statements are the opposite of each other, you just need to formulate one of them first, and then the other one is going to be automatically created. It's just going to be the opposite of the other one, all right? So now we're going to look at the examples of hypothesis test or hypothesis sets, null and alternative, H0, HA, null hypothesis, alternative hypothesis. For one sample test of population mean, mu. So when we are testing the value of one sample, one population, the value of the population mean for just one class, one school, for example, one population to see if it's less than a specific number. So if our research question is to see, for example, if the average GPA of CSUSM student is less than 3, so that would be our research question, all right? So average GPA of CSUSM student less than 3. So mu0 is the hypothetical value, so it's going to be 3 mu0. So we want to see if the mu of GPA is strictly less than 3. So now when you have this as your research question, the opposite of this, so if you have strictly less than 3, the null will be greater than or equal to 3. If your research question, research hypothesis, or alternatively, your alternative hypothesis, if that is to see if the average GPA of CSUSM student is greater than 3, right? If you're testing to see if that statement is true, that would be your research question, that would be your claim. You put it in alternative. And again, the opposite would be basically the null hypothesis, and it's simply the sign. So equality always, again, goes to the null hypothesis, and we always have strict sign, strict relationship that does not contain equality. Those go to the alternative hypothesis. And we may also want to see if the average GPA of CSUSM student is different from 3 or not, or in other terms, in other words, we may say, can we test to see if the average GPA of CSUSM student is equal to 3? Either way, this is going to be a two-tailed test. So we call these two tests, these two types, and a hypothesis test for population mean of one sample or one population is one of the 3 forms. So we are basically capturing all the possible cases. So the first 2 are called one-tailed type of test, one-tailed test, and then the last one is called the two-tailed test. The reason for that, I'm going to explain when we're dealing with the conclusion part, but the reason for that is because in here we are rejecting the null hypothesis if the sample mean that we take, we reject the null hypothesis and take this one, alternative hypothesis, if the sample that we take is extremely less than, the sample mean in this case is extremely less than mu0, or in our example, in the CSUSM average GPA case, if the average sample that we take and we found the sample, the average GPA of the sample, if that number, X bar, is strictly less than 3, let's say we get 1.5, then we have enough evidence, we will have enough evidence to take this one and reject this one, all right? So we reject the null hypothesis at one side. We just look at the lower side. Here, we reject the null hypothesis only if the sample mean that we find and calculate is strictly greater than, considerably greater than mu0. If that is the case, we can now go ahead and reject the null hypothesis. So we reject at the upper side of the distribution. Here, though, we reject at both sides. So if, let's say, we want to see if the average GPA of CSUSM students is equal to 3, and what we're going to do, we're going to take a sample and find the sample mean. If the sample mean happened to be significantly larger than 3 or significantly larger than 3, either way, significantly larger or significantly smaller. Either way, we are going to reject the null hypothesis. So that's why this is called two-tailed test. We reject at both sides. This is called actually, and these two, both of them are one-tailed. This one is also called a lower tail test, or a left tail test, or lower tail test. This one is called the upper tail test. Again, the reason is because for this one, we're rejecting at the lower side of the distribution. We just reject the null hypothesis if the sample mean is significantly lower than the hypothetical value here. Here we reject the null hypothesis if the sample mean that we take is significantly larger at the upper side of the distribution.